recording, so I won't say anything bad. Okay, so 2.11 today, one day of 2.11, and then we have 2 days of 2.12, and that's the end of the new material. So Friday and Monday are 2.12, and they're a lot easier. So some of this stuff has been a little hard. And then we have a test review for Tuesday and Thursday, technically, because Wednesday is the fast test. I will see you guys for 33 minutes on Wednesday, so we can just use that as more review time. And then the test is Friday and Monday. This is a shorter test. It's only 12 multiple choice questions and 2 FRQs over 2 days. So it's going to be very manageable to do the review and make sure you guys understand every bit of it. I expect these test scores to be really high, having so much time and it being a little bit shorter. And then we'll start exam review after that, okay? So this is probably our last, kind of challenging lesson, all right? Properties, I'm going to skip to this right here. Continuing on with log functions, let's just go over some properties of them, some facts that we need to be familiar with. And this is the parent function, right? Before there's any shifts or stretches or anything that we talked about yesterday. The x-intercept is 1, 0, and there's no y-intercept. And this, of course, again, is on the parent function. First, we can move, and that will change. The y-axis is your vertical asymptote. This, I think, is really, really helpful, especially for an example we're going to do in a second. When b, your base, is greater than 1, the function is increasing, and when it's less than 1, the function is decreasing. That terminology is going back to quarter 1 when we talked about increasing and decreasing AROC and everything. What that means is this. So if my b value is greater than 1, my function is increasing. That's like a visual thing. As I read my graph left to right, my y values are going up. The points are going up towards infinity. That's an increasing function, okay? If b is less than 1, that's another way of saying this, right? Greater than 0, but less than 1, just not negative, can't go into negatives. The graph would be decreasing and would look like, I'm not good at drawing it, it's freehand, but you get the idea. That's decreasing. A function is decreasing. You can think of it as like a line with a positive slope. That's an increasing function. A line with a negative slope would be a decreasing function. They have the same end behavior. Okay? That one I don't care about. These graphs are smooth. They're continuous. They're predictable. We know they're not going to have a minimum down here and turn around and come back up like a parabola or something. Okay? So just some facts to talk about there with logs. So we're changing this bottom part a little bit, making it a lot easier. All we care about is A and B. So what we're doing here is finding the domain of each function. Let me just do my attendance while you're writing that little change. So Ryan and Ryan, both Ryans. Kayla. Also, don't forget, I moved the quiz due date to next Wednesday. Gavin and Cammie, you might not have known that. I moved it to next Wednesday. Okay. Oh, glad I'm here. Okay, glad I'm here. Okay, so what we're doing here is finding the domain and asymptote of a log function without the graph, without the table of values. Really, really easy. We get it right from here. What we do is we take that x plus 5 and we set it greater than 0, not greater than or equal to. Where that comes from is our parent function. All of our points are to the right of the y-axis where everything's positive, okay? And so when I solve this little one-step inequality, I get negative 5. So let me write it in interval notation and then let me explain it. So we want from negative 5, not including it, to infinity, right? There's my domain. I don't need a graph for it. It's that easy, okay? Now let me try to explain it to you, and then I'll talk about the asymptote. So if my parent function is at 1, 0, okay? It's going something like this. And I have to graph this one. That x plus 5 in parentheses we talked about yesterday moves your graph left 5 places, right? That's left 5. So I couldn't count last period. It's so frustrating. So I'm going to take this point and go left 5. So it'd be 1, 2, 3, 4, 5. So my new graph would be like here, right? Just moving the graph 1, 2, 3, 4, 5 places. This is negative 4 right here. So where's this negative 5 coming in? Well, negative 5 right here is your asymptote. Negative 4 is your last good point. Remember when we did this on our calculator, it'd be like negative 4 and then go into error, error, error. That's because at negative 5, we have an asymptote. There's still points in between these, okay? So that's why we say the domain is from negative 5 to infinity. But this little bitty inequality gives us our domain, and it gives us our vertical asymptote, which matches that number. It should make sense. Picture it. At negative 5, you have an asymptote, and then we want all the numbers to the right of it. Okay? Now, I'm going to go off topic for a moment, but there's a reason for it. When I take this 5 minus x, and I set it greater than equal to 0, and I solve it, there's a lot of students that would make mistakes here. And I want to talk about, there's a test called the PERT test. Some of you know about it, some of you have taken it. If you don't know about it, ask me about it another time. But it's the test that we take to get into dual enrollment classes. It's placement tests for math and whatever they do on the other side of school. English, reading, whatever it is. Math is all I know. And it's a 30-question multiple choice test that every single one of my students should be able to get a perfect score. We don't always, because we don't review really quick before it. The hardest level of questions on the PERT is factoring, and it's everything below factoring, okay? So yes, factoring, whatever, but most of you are fine now with that. Where we mess up is how do you subtract decimals without a calculator? That's easy math. I could review it with you in 10 seconds and you all would be back in it. But when's the last time you did it, right? Like things like that. How do you change 4/5 into a percent? You learned it at one point, you could maybe figure it out, but you might make a mistake, you forgot. So, and this is something, and this is why I'm talking about this. So as more of a side note, if any of you are planning on taking the PERT test, I'm going to upload a review to Canvas. If you want it, you can ignore it if not. It would take you guys probably 30 minutes to review for it. So if you are planning to take the PERT math, I can only speak about math, please review before you go. Because you need like a 114 or 121 to get into college algebra. You need like a 122 or 23 to get into college algebra, which is your first math class in college that you get credit for. We'll talk about it another time if you have questions about it. But all of you, every single one of you should have no problem testing right into college algebra. Okay, but just review a little bit. So back to this problem. There is a reason I was talking about that. When we solve this, we would subtract 5, right? Negative x is greater than negative 5. And then I don't think any of you would have this problem, right? You know that's a negative 1, so you would divide by negative 1. What do you have to remember right here? Back from a long time ago. Yeah, flip your inequality symbol. I mean, when's the last time you had to do that? Maybe you did it for a minute in Algebra 2. We haven't done it this year, I don't think. But anytime you divide by a negative number, you have to flip your inequality symbol. That's a PERT-style question, right? That would be easy to get wrong. You can do really high-level, almost calculus work right now, but we forget some of those little things. So that's all I have to say. All right, so we would write this in interval notation. So remember, if we're pointing towards negative infinity, we have to start with that. We always do smallest to biggest with interval notation. And we'd have a vertical asymptote at x equals 5. Okay? So just a quick, easy way of finding your domain and an asymptote without having to graph or something. We have 3 questions in our homework, but you just do that. Anybody have a question about those? Please, right. Okay. Top of the next page. This is an excellent little quick visual of all the different things that happen with logs. Where are they going? What's going on? Okay, so we have 4 functions in algebraic form, f of x, g of x, h of x, k of x. And then we have 4 functions in graph form, a, b, c, d. We're going to match them up. So starting with f of x, we have like a basic parent function, right? Log base 2 of x. There's no negatives anywhere or anything. And what we just talked about is that when your b value is greater than 1, it's going to be increasing, and all of our points should be to the right of the asymptote, which is y equals 0. So which one goes with f of x? C, right? All of my points are to the right. I'm increasing. So C and f of x go together. Okay? Now we're going to talk about a few pieces of information about this graph. We've been talking about concave up and concave down. This one would be concave down, and I'm totally abbreviating, so if you need to write it out, feel free. Concave down, right? The function is, we just said this, increasing, right? It's rising from left to right, positive slope, all that. We're about to go into exam review. That means we have to go back to thinking about what happened in quarter 1. I'm going to bring back an oldie but a goodie. What about the ROC? We also call it the AROC. This is the rate of change. This is a great time for me to bring it back and review with you really quickly. The rate of change is the slope between any 2 points on a curve, okay? So when we talk about the AROC, we are unfortunately having to use the same words as we use here. It's increasing and decreasing. And a lot of us, my students, got confused about this, okay? So by the time I'm done with these 4, you'll remember them again. But what this is asking is, as I go left to right, are my slopes increasing or decreasing? Meaning the actual values, like 1, 2, 3, 4 is increasing, 4, 3, 2, 1 is decreasing, okay? The way we tell is by the concavity. If you are concave down, your slopes are decreasing, D and D. Okay? What that means is if I found the slope between a bunch of different points along this curve, as I travel along it, left to right, the numbers would be getting smaller. For example, the slope could be 1, then it could be 1/2, then 1/4, then you know what I'm saying? So the numbers actually get smaller. Completely different way of looking at it from the function being increasing and decreasing. Okay, stay with me. This next one, g of x, is exactly like f of x, but with a negative in the parentheses. Where's that going to flip us? Over which axis? The y. So which one of those, take a spatula like a pancake and flip it like a pancake. Which one is it? A. Right? Just flipping it right over. So this one is concave down also, right? It would not hold water. You couldn't put water in it and hold it. Concave down. Is our function increasing or decreasing? Decrease, going down, decreasing, right? That's a visual thing. And really, so is your rate of change. If it's concave down, your slopes are decreasing. So I wish we had different words for those two, but we don't. They share the same word, decreasing, increasing, but they mean different things. Okay? H of x is the first graph, that parent function, with a different flip over the x-axis. So we've got 2 choices. So which one is it going to be? B. Because we wouldn't go, this is all the points in D are on the other side of the y-axis. We're still over on the other side. We're just taking this graph and flipping it. So it's just a flip of that. So we wouldn't go over to the other side. So it's B. This one would hold water, right? Concave up. Our function is decreasing. And our rate of change is, yeah, I don't have a cutesy thing for you. There's only 2, though. We have concave down or concave up. And we have decreasing and increasing. So if we know the D's go together, increasing is the other one, right? That's just the way to do it. And last one, I think you would all agree that D is K of X. Now what's different here is the B. The B is decreasing. So it would have started like that, and then it flipped over the y-axis and became that one. Okay? So concave up, right? It would hold water. Our function is, careful, what is it? Increasing. Remember, we always read a graph left to right, okay? So it's increasing. And if we're concave up, our rate of change is increasing. Okay? Good with those? All right. We have one last example, and it's a super important one. This is where you have to go back to page 225 to get example 9. We're also going to be getting a homework problem out of that set of homework as well. Sorry, I hate having to make you guys rearrange your stuff, but there's a reason I do things, believe it or not. You guys, tomorrow is December. The heck? Okay. You find it? Guys, this is an FRQ. There's a version of this in your homework today. There's one of these on your test review, and there's an FRQ on your test, just like this. So this is a good one, an important one to take good notes about. But remember, there's going to be a couple places you might be like, ooh, I'm not feeling super certain about that. We have a lot of time to review. And you're going to have time to do homework after this, so if you need me to go over something with you, I will. But just try and stay with me for now. Okay. This is the 5th time I've done this problem. Okay. So an exponential function in this form is given. Oh, okay. You like my acting? Oh, okay. So they gave us an exponential function. They told us what form. They gave us points. We just have to answer questions. Yesterday when we did this, we were given, remember 10, 11, and 12 in our homework that I did with you? We were given the chart we had to decide. So we'll talk about that a little bit too. So the first question is to describe the end behavior. Now we don't have a graph to look at. Like if we had a picture, really easy. So we're going to have to kind of think about what's happening at the end by looking at what's happening in this table of values. So let's start by setting up our limit notation, because this is something you have to do properly, okay? And again, you don't have to use a cursive L. You can make it just a regular L, okay? The limit of whatever the name of the function is we're talking about in this problem, which is g of x, it's always x approaching something. I'm going to leave it blank for a second, equals. So we're going to put something there, and we're going to put something there. That's our left side. And then we also have to do our right side. There's always two sides, right? There's a left and a right to all functions. So we have to write it twice. Okay. So let's do the right side first. Look at my x values. We have to look at x's and y's. The x's are going up. 3, 4, 5, 6. Going up by 1, nice and happy. And our y values start out yucky decimals. Oh, here, look, 2, 3, 5, 9, 17. From what we're seeing, the x's and y's are increasing without bound, is what we say, without a boundary. There's nothing that looks like it's stopping it. It looks to us, right, that as we go to the right towards positive infinity, our y values are going up to positive infinity. Okay? So the right side of our graph should be going up. Left side, a little trickier. Okay, looking at my x values going down, 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 down. And then something's going on here. There's these weird little decimals. When you see that, you know something's happening at a number really close to that. It's like they slowed down and got bunched up, kind of. They weren't allowed to, like, expand out towards the negatives. So when you look at this, this should be a quick, I think you should be able to, visual of what our y value is, what our limit is, where are we heading, what's the number we're heading to in the y's. That's this number, okay? That's the y value. This is what x is approaching. And we're just going to use -4 because that's the smallest number they gave us. But we say -4 from the right, okay? Now, that is confusing a little bit. It's new. It could be tricky. Let me tell you this, though. When you finish the problem and you get to this, like your FRQs a lot of times are lots of pieces. There's no rule that says you can't go back and change something because, oh, I should have put a positive in front of that infinity sign or something. So just know, like, maybe you start and you say, okay, I need to double check that once I have my graph to see if it makes sense, okay? Next is B. What is the value of K? Now, there is something, a little tip I will give you. When we're working with logs and exponentials, and that's what we've been doing. We're going back and forth between them. Exponential functions have horizontal asymptotes, and logs have vertical asymptotes. This is another one of those things I have trouble this is another one of those things I have a hard time, like, remembering. So, at the risk of making a fool out of myself, I'm going to tell you how I remember these, and then you can laugh at me. I don't care. Use my memory thing, or just learn your own way to memorize it. But it's good to know. So this is a horizontal horizon. Horizontal. So I think in my head, experience the horizon, okay? And then get logs on vacation. I need logs for my fire. I'm in a cabin, okay? It might help you. Or he's like trying to be polite. So. Anyway, the number that you're getting really close to right here, that's a sign that's an asymptote. That is your K value, and that will make more sense in a second. So A and B are a little tricky, okay? And C kind of is too. After C, we're in good shape, okay? Now listen, yesterday I said to you, look at a table of values. Look what's happening with the X's. Okay, we're increasing by 1. Now let's look what happened with the Y's. What are we multiplying by? Oh, we're multiplying by 2, we're multiplying by 3, we're multiplying by 5. It's exponential. Well, that's not happening here. But they already told us that it's an exponential function, so what's wrong? I'm going to tell you, there's nothing wrong, but these are different from the ones yesterday. So this is asking output values change proportionately as input values increase in equal length intervals. Use this fact to determine the base. So we're going to find B somehow with what's going on. So one other thing, a little survival tip here. Let's not mess with the decimal part of the XY chart. They gave us enough points that we can really focus on this section to see what's going on, because we know they're all points on the same graph. But these are harder to deal with, and they gave us enough points that I can find what's going on here, and then I just know what's going on down there. If they didn't give us all those points, I would be forced to deal with those decimals. Okay, so just something to think about. So what are we multiplying by here? Nothing. There's nothing I can multiply 2 by to get 3 or 3 by to get 5. So I look for another pattern. And what you're going to notice is we are adding something. Let's see what we're adding, because sometimes there's a hidden pattern in there. And there is for this one. So as I go through, I'm seeing what we're adding by, and I start to realize something. And that is that these numbers, 1, 2, 4, 8, 16, and these are really common ones. You will see these definitely again. What's happening here is these are the solutions when I use a base of 2. 2 to the 0 is 1. 2 to the first. 2 to the second. 2 to the third. 2 to the fourth. It's kind of like second differences. Remember we had to do all that? You have to look a little deeper in the XY chart to find the pattern to get our base of 2. Why was it hidden? Because the ones we did yesterday, they're nice and easy ones, didn't have an H or a K. They were just the parent function. So before we moved things left, right, up, and down, it would have just multiplied by 2. But when we start moving those around, that easy, simple multiplication goes away. It's hidden in there, and we found it. And you'll see that it's going to work really beautifully here in a second. Okay? So you'll see this again on the homework, on the review, so we'll practice that. But it's hidden in there, but it's there. Okay? Algebra. Yay, we're good at this part. We're going to use a point out of that table. They gave us 4, 3. Okay. We're going to use the B that we found, the K that we found, and then we're going to use those 4 variables, X, Y, B, and K, to find H that we don't know, so that we could actually write the equation that matches this. So we are going to use X is 4 and Y is 3, and by the way, any point in there would have been fine, any X, Y, it wouldn't matter. K and B to find H. Because we know in algebra, if there's 5 variables in an equation and we have 4, we can use our algebra skills to find that missing variable. And we've done that before. Let's do it now. So y equals b to the power of x, so that's 4, minus h, I don't know, plus 1. Okay, so I'm just plugging right into y, b, x, k. And so We are algebra people. We know we're trying to get h by itself. So instinctively, I'm like, oh, let me move the 1 over. Trying to get h by itself. And I get to this step, and I'm like, wait, what do I do? H is still up in the exponent. I don't know how to get that down on the ground. But guess what? You do have a way. You already learned it. Anybody see it? Don't know. When you have like bases, so let me say it differently. If 2 equals 2, then 1 equals 4 minus h. Remember the like bases we did the other day? Subtract 4. Yep, subtract 4, you'll get -3. And then divide by -1, you'll get +3. Ashton, wake up. It's rude. H is 3. So our function is g of x equals b to the x minus, oops, I almost wrote h, x minus 3, sorry, plus 1. We don't plug x and y into our final answer. Thank you for letting us borrow you to help us find h. But think about it, when you write something in slope-intercept form or quadratic in whatever form, x and y are always x and y. You don't plug numbers in for it. So sorry, that says x minus 3 up there. That is the equation of that. So this is a great moment on an exam or a test to say, did I get this right? Let me plug one of these x's in and simplify it and see if I get y. And trust me, it works. Okay? So this is the graph of 2 to the x moved right 3 up 1. That's why our numbers are messed up. All right? They want us to find the domain and range, but they're not the boss of us. We're not going to find it right now. It's easier to find it once we graph it. So I like to look at a graph to find domain and range since I'm graphing it anyway. Almost there, guys. Last push right here. Find the inverse. Inverse. Flip the x and y, solve for y. So I'm going to go slowly through this. It's been a few days since we had to write exponentials as logs, which is what we're doing. Okay? I switched x and y, and I'm going to solve for y. So remember, this is an exponential function. Its inverse is a log function. So I have to rewrite this guy in its log form. Remember I told you we do that a lot, going between the two forms. So first thing I'm going to do is get the base by itself. Kind of like I explained whatever day it was yesterday. You have to get the log by itself, clean up the problem before you rewrite it in the exponential form. Same thing here. We need to get the base and its exponent on one side by itself. Okay? Now we can write this exponential function as a log function. We start by writing the word log. Logs have bases. The base of this log would be the same as the base of the exponential. This is called a base 2. So here's our base. Remember my weird little way of doing it? Leave a space. Our exponent is a loner. He's up in the sky by himself. He likes to be by himself, so we're going to give him his own side of the equation by himself. And that leaves the x minus 1. And it's going to go in our leftover spot. And yes, you must put the parentheses. We're saying x minus 1. All of that is part of the log. And then one more step, just to add 3 to the other side to get y by itself. The final answer is log base 2 of x minus 1 in parentheses plus 3. So if you forgot the parentheses in this red step, I think when you went to this step, you would have caught it. It would have looked weird, x minus 1 plus 3. Okay, so I'm hoping that that would have helped you remember. Last thing we have to do is graph them both, domain and range. Okay, let's do this fast, guys. I'm tired, you're tired. We don't need to use our graphing calculator. We've got points. Let's just use those nice points right there and graph them. Just be careful. It doesn't have to be perfect, but this is counting by 2s, so be careful when you're graphing. So 3, 2, and so on. And you don't need to graph all of them. This does not have to be perfect. When I grade these, what I'm looking for is if you think I'm getting out a magnifying glass, which is what I would have to do, and like make sure every point's in the exact right place, you're crazy. There's no way I would do that to 120 tests. I'm looking for the general shape. Where's your asymptote on here? It's at x equals 1. Sorry, y equals 1. Horizontal, hey, right? This is y equals 1. And like I said, let's just do the domain and range real quick. The domain of this, I hope you're getting better at this. It kind of doesn't take as long. We're going to the left forever, and we're going to the right forever. There's no vertical stuff blocking this, so it's all real numbers. And the range would be 1 to infinity, not including it, right? Everything above 1. And easy peasy, flip those points in the, here, remember? X and Y, flip, flip, flip. Pick any of them you want, graph a few. Fun fact, we know that there's going to be a vertical asymptote at x equals something. It's going to be the same number always. That's one situation we don't change the sign. It's just if y equals 1, we flip it to x equals 1. So it's going to be right here. Just helps us finish our graph. And I want to see the asymptotes on your graphs. Domain and range, flip it. Let's flip these, right? Find those shortcuts. Instead of staring at the graph and trying to find the points that were for this graph. Remember, B's and R's split, X and Y's. Okay? I just threw a whole lot at you. I know I did. Yeah. And so now I'm going to tell you what your homework is, but please write it down so I can then take my 45 minutes to try and organize the key up there. Like I said, you're going to have to pull page 232. Look, this is, so let me explain your homework. I'm sorry. So B20, and you can go ahead and write it wherever you want. Okay, I'm on the 211. You're going to do the FR2, which is number 14 on page 232. That goes with the problem we just did. Then back to 2.11. And you're doing 9 through 12, which is the domain questions, and number 19. Okay, that's from 211. Okay. So please, please, please write that down. And if you need me to explain that better, I will be around momentarily. 19 at the end there? Yeah, 19. Oh my God, my head hurts. Okay. Alright, so whatever order you want to do it in, doesn't matter. So 9, 11, 12, 19,